Let's review some concepts related to regression, correlation, trend, confidence interval, and then finding outliers or discovering outliers. Doesn't mean we get rid of them, but just statistically saying, how can we identify outliers? There's some data here. This is the mixed fruits data from European salmon. It has to do with the sum of quantities sold. And so what I'd like to do is graph this day versus quantity sold and see if there are trends and look at the regressions and things like that. Generally, you want to work with scatter plots because these numbers here may not be exactly sequentially oriented. Like here's 1, 2, 9. Well, that's a big skip. You skipped 3, 4, 5, 6, 7, 8. And then the rest are all okay. If I did this just as a column chart, the trend wouldn't be right because it's assuming that each one is equally spaced. These are all pretty equally spaced, but if I try to insert a scatter chart, I can't do that in a pivot chart. So I'm going to copy and paste this over here. About there, this is the date or the day, and this is the quantity sold that day of the mixed fruits. And what I'm interested in doing is finding the regression line through this bunch of data, seeing how well this data is correlated, what kind of trend, and identifying outliers. So the first thing I'll do is insert a scatter chart for this data, and it looks like that. It doesn't look very good, but we might see that it looks like there's some sort of a trend for these the upper bounds, and then for the lower bounds they seem to be pretty consistent. So you might be able to break it up that way. But for all this data, if you want to get a regression line, you have to right-click on the data, add a trend line, and it's set up for linear. That's fine in this case. We're going to display the equation, the r squared. And there's the equation in the r squared. It's not a very good r squared, I mean in general. If we just did this lower data and fit a line to it, we'd get a really bad r squared. But it's almost a perfect line. So it's looking, the r squared is really good for trends. Is there a good trend? This indicates, well, there's not really a good trend in this data. So maybe average is good enough. Maybe. I mean, to predict the quantity sold. Just use the average. So that's the regression line, and the correlation is 0.05. That's not good. Closer to 1 is a lot better. And the trend is about, for each day, you're increasing about 58. That's what the trend is, the slope. So I could get this same data. Well, first of all, I'm going to take the average equals average of all this. And that's the average. I don't need that much precision. Here's the average, and I'm interested in the standard deviation of the sample or the population. They're going to be pretty similar in this case. So there's the standard deviation, and if I'm interested in an outlier from this average, then a 95% confidence interval would be 2 times this plus the average. So anything above about 75, 61 would be considered an outlier from the average. Reduce these, don't have near that much precision. So this would be an outlier. Anything bigger than that would, if you consider 95%. Now that's an outlier from the average. So the average is about 34, which is right about there, straight across. There does seem to be a little bit of a trend here. So if we want to find the standard error of the y estimate, so here's the y estimate, and there's x. The standard error of the y estimate is STEYX. Here are my y's, and here are my x's. And this is the error associated with some data points. So say I pick 20, the data point 20 times 59 is 118 plus this is about 34, and well, it's about that point there. And what this number here is saying is that there's an error associated with this estimate, with this trend line, and it's about 2,000. So if I went 2 times that, or about 4,000, that's the 95%. So that's a bigger estimate. So say 20 is about there, and I add 4,000, that goes to about there. So there's a bigger. The standard error of the y estimate takes into account this trend line. So they're different. That's all I'm saying. This is for the average. This is the standard error associated with the forecast based on this trend. So that ought to cover it. If you want to see what happens if I say sort these low to high and say, gosh, it looks like there's some sort of trend if we just look at the numbers that are above about 4,000. So if I was to get rid of all of these, hit delete, that's a better R squared. It's about 50%, a lot better than 10 times better R squared. And if I thought, well, I wonder what the R squared is associated with this, all these low numbers. It's like it's consistently low. It's like the lower bound. If I was to get rid of them, there's an R squared of 0.266. So you can kind of play around with this. These outliers, you need to be careful. It doesn't mean you throw them away, but it's something to consider, something to investigate. It was a data error entry. What causes these outliers?